All right, guys, welcome to the normal distribution, chapter 11, section 6. The normal distribution takes probability along with the measures of central tendency, the measures of variation, and the measures of position and put them together into one unique unit referred to as the normal distribution, which is very important to understand statistics. In this video playlist, we're just going to be introducing what the normal distribution is. For chapter 11, section 7, we're going to then talk about its applications to real world problems. When we do research, we use the normal distribution curves and its properties to find evidence to support or reject a claim. That is called hypothesis testing, which you will focus on in the second half of Statistics 250. Now, if a random variable has a probability distribution whose graph is continuous, bell-shaped, and symmetric, it is called a normal distribution. This graph is called a normal distribution curve. You will be using normal distribution when either you see the word normal distribution, standard normal distribution, or identify what we call a z-score. Here are some properties that you need to know about the normal distribution. A normal distribution curve is bell-shaped, and I'm going to draw one in a few minutes. The mean, median, and mode are equal and located at the center of the distribution. Well, the median is the middle, so it has to be at the center. Once again, going back to equality between the mean, median, and mode, we learned that in the measures of averages. When the mean, median, and mode are exactly the same, or in reality approximately the same, then we have a symmetrical distribution, and that represents an overall consistency within our data set. Now, another thing that we need to know is that the curve is symmetric about the mean, which is equivalent to saying that its shape is the same on both sides of a vertical line passing through the center. And remember, it uses the word mean. The curve is symmetric about the mean. Now, remember from the measures of variation, the standard deviation is the average distance between each data value and the mean. Therefore, we will be using the standard deviation along with the mean, along with probability when we are drawing a standard normal distribution curve. The area under the part of a normal distribution curve that lies within one standard deviation of the mean is approximately 0.68, which is 68% as a percentage. Within two standard deviations of the mean, that is going to be 95% of data. And with three standard deviations of the mean, that is going to be 99.7% of data. And once again, those are probabilities. And the area under the curve, the area under part of the normal curve, is referred to as a probability. So we're going to see how to work our normal distribution curve, and then we're going to understand how to find the probability based on the normal distribution curve. So let's look here. It says the batteries of a certain manufacturer has a mean lifetime of 870 hours with a standard deviation of 70 hours. Assuming that the lifetimes are normally distributed. So when we see normally distributed, we know that we're using a bell-shaped curve. Complete the following statements. Approximately blank percent of battery lifetimes are between 730 hours and 1,010 hours. And this is multiple choice. A, 68%, B, 75%, C, 95%, D, 99.7%. Okay. And then B says approximately 68% of batteries have lifetimes between blank hours and blank hours. All right. So it says normal distribution, which means I need to draw a bell-shaped curve. Let's scroll down for a second and let's draw this bell-shaped curve. And it should look something like this. And this is not drawing a scale, by the way. Or perfectly, because I can't draw. So you draw some sort of bell-shaped curve, and then you draw a line down the middle. This middle value is going to be the mean. And in this case, we're going to be using the sample mean, which is x bar. Some professors may use mu. And mu is the population mean. To keep it consistent with Alex, I'm going to use x bar, which is going to be the sample mean. But sometimes you're going to see mu, which means population mean. They can be interchangeable in this case. And the mean is going to be 870. Now, we're also given, let's scroll up, standard deviation of 70 hours. To reiterate, the standard deviation is the average distance between each data value and the mean. So what I'm going to do is, in purple, I'm going to draw 3 units on the right side of the mean, 3 units on the left side of the mean. The distance between the center and each unit moving to the right or moving to the left is called a standard deviation. And each standard deviation is worth 70 hours. So if my mean is 870 and each standard deviation is worth 70 hours, I'm going to add 70 to 870 to get to one standard deviation above the mean. 870 plus 70 is 940. And then you repeat the same process. To find the next value, you're going to add 70 to 940. 940 plus 70 is 1010. Plus 70 again is 1080. And that is how you work your standard deviations. Now remember, the symbol for standard deviation is S, and that is sample standard deviation. Now, you also may see this symbol right here. And we call this symbol as lowercase sigma. Lowercase sigma. And that means the population standard deviation. And Stats 250, you have a more in-depth meaning of which each of those represents. And how to calculate the difference between a population standard deviation and a sample standard deviation, although we already did sample standard deviation. Okay. Now, remember, the standard deviation is 70. Now, I'm going to focus on the left side of the mean, which means I'm going to be decreasing by 70. So 870 minus 70 is 800. Subtract 70 again, that is going to be 730. Subtract 70 again, that is 660. So now we created the normal distribution curve. Let me erase some of these data values that I do not need down here. Going back to the notes, it said that 68% of the area lies within one standard deviation from the mean. So based on the normal distribution curve, 68% of your data will lie in between one standard deviation from the mean. It says 95% of your data lies within 2 standard deviations from your mean. And about 99.7% of your data lies within 3 standard deviations from the mean. 99.7%. So actually, let me redraw my blue one actually so it can make better sense in terms of the graph. And that's within that interval. So let's answer the questions based on the figure that I have constructed. It says approximately what percent of battery lives have a lifetime between 730 hours and 1010? If you look here, between 730 and 1010, that is about 95%. So the answer will be C, 95%. And B says approximately 68% of battery lives have a lifetime between what 2 hours? 68% is 1 standard deviation from the mean. So that is going to be 800 hours and 940 hours. And that is the answer to the question. All right, guys. I'll see you in the next one. Take care.